Analyzing early World War II air combat, U.S. Navy Command came to a sobering conclusion. Their fleet of carrier-based aircraft was rapidly aging. It was already noticeably falling behind the fighters of their likely adversary, Imperial Japan. The primary American carrier fighter, the F-4F Wildcat, simply could not compete on equal footing with Japan's newest fighter, the Mitsubishi Zero. The American airframe had practically reached the end of its development cycle. At the same time, the Imperial Japanese fighter still seemed to possess massive untapped potential. Meanwhile, the United States being drawn into the global conflict was only a matter of time. With this in mind, in June 1941, the Navy signed a contract with Grumman. The goal was to heavily redesign the Wildcat to achieve a massive leap in performance. First and foremost, the Navy needed drastically better speed and maneuverability. Grumman's chief engineer, William Schwendler, made a bold decision. He wanted to fit the airframe with a much more powerful 1,600 horsepower engine. This was the R-2600 from Wright's famous twin Cyclone family. On top of that, Schwendler decided to eliminate the two main flaws of its predecessor, the F-4F. These were the narrow track landing gear and the inefficient small-diameter propeller. Naturally, a heavier engine, larger fuel tanks, and a higher ammo capacity changed the aircraft. They meant that the overall dimensions and gross weight of the fighter increased significantly. As a result, the new aircraft turned out to be an absolute giant. It became the largest single-engine fighter ever built anywhere in the world at that time. The landing gear was radically redesigned. Instead of a complex, manually cranked gear that retracted into the fuselage, the aircraft featured tall, heavy-duty gear struts. They folded flush into the wing. They retracted aft along the flight path and rotated 90 degrees to lay flat. The overall configuration changed as well. While the Wildcat utilized a mid-wing design, the new fighter shifted to a low-wing layout. The fuselage was also completely redesigned. It abandoned the old barrel shape for a new, slightly pear-shaped cross-section. The wing structure saw equally massive changes. It was built around a single main spar, supported by front and rear subspars. However, engineers successfully retained Grumman's proven stow wing folding mechanism from the Wildcat. This helped to save precious space on carrier decks. The fighter's armament was truly formidable. It packed 650 caliber machine guns. They were mounted just outside the propeller arc, located out in the folding section of the wing. The guns were grouped into tight clusters of 3 on each side. Closer to the fuselage, self-sealing fuel tanks were safely housed right at the wing roots. To improve the aircraft's turn rate and horizontal maneuvering, the wing utilized a thick NACA 230 series airfoil. To cut down on drag during level cruising flight, the wing's angle of incidence relative to the fuselage was set to 0 degrees. However, another problem arose. Because the new aircraft's weight had jumped by 60%, pilots had to fly with a much higher nose-high attitude to safely land on the carrier deck. To solve this, the engineers came up with a clever solution. The engine's thrust line was intentionally angled down by 3 degrees. This unique design feature, combined with shifting the cockpit slightly forward, drastically improved the pilot's forward visibility. This slightly drooped nose would later become the signature, unmistakable silhouette of the F6F Hellcat. All flight control surfaces were built around all-metal frames. The elevators and rudder were fabric-covered to save weight. Meanwhile, the ailerons and flaps were skinned in tough duralumin. Despite having a much more complex internal structure, the new fighter, named the Hellcat, turned out to be a lot easier to mass-produce than its predecessor. Its fuselage had a much simpler shape, and the metal skin panels were mostly flat or featured simple curves. They even skinned the aft fuselage with metal sheets just over 1/10 of an inch thick, using simple lap joints to overlap them. This was done to speed up production on the assembly line. The designers figured that these overlapping seams on the fuselage wouldn't create much parasitic drag or affect the fighter's overall speed. Fun fact, later on, during fleet service, ground crews in the field would often fill and sand down these seams and paint over them. Thanks to the simple modification, the top speed of these smoothed-out aircraft actually went up by about 6 to 9 miles per hour. For the airframe, the engineers also relied heavily on standardized stamped parts. Thanks to this approach, by early 1942, the first 2 flying prototypes of the future Legend were completed. They equipped the first one with a standard Wright R-2600 engine without a supercharger. The second prototype received an upgraded variant of the same engine. It featured a supercharger for reliable high-altitude performance. The highly anticipated initial flight tests for the first prototype kicked off on June 26, 1942. That was the day Grumman's chief test pilot, Selden Converse, took the massive fighter to the skies for the first time. By late July, the second prototype joined the flight test program. All these intense and absolutely vital tests for the U.S. Navy took place at Grumman's restricted Bethpage Airfield on Long Island. Test pilots loved the new aircraft right from the start. It was surprisingly easy to handle and was incredibly forgiving on landing. It also showed solid maneuverability in level flight. But there was one major problem. The aircraft was frankly underpowered. Because of this, it had a low top speed and a poor climb rate. It was also pretty sluggish when pulling into the vertical. Grumman's chief engineer, William Schwendler, found himself facing a tough choice. Option 1 was to reduce the aircraft's gross weight by sacrificing structural strength and stripping away some of the armor. Option 2 was to drop in a much more powerful engine. They quickly scrapped the first idea. Everyone remembered all too well that the Hellcat's main rival, the Imperial Japanese Navy's Mitsubishi Zero, suffered from a lack of armor and a lightweight airframe. That is why those fighters caught fire so easily. They also structurally failed from even minor battle damage. The Americans had no intention of repeating that mistake. So that left only the second option. The U.S. Navy fully backed it. Soon after, they installed a brand new Pratt Whitney R-2800 engine into the second prototype. This engine cranked out a solid 2,000 horsepower. The old prop was swapped out for a more modern 3-blade Hamilton Standard propeller. This updated version received the designation XF6F-3. They decided to upgrade the first prototype as well. They installed the same engine, but with a 2-speed supercharger. This variant became known as the XF6F-4. However, flight tests showed that this supercharger setup was extremely unreliable. Because of this, they ended up dropping it entirely. The engineers made a few more minor tweaks to the design. They slightly reworked the main gear wheel wells and got rid of the propeller spinner. In this finalized, fine-tuned form, the fighter went into mass production as the F6F-3 Hellcat. To meet the massive demand for the new aircraft, Grumman actually had to build a completely new manufacturing plant on Long Island. Interestingly enough, the Canadian branch of Vickers also wanted to produce these fighters under the F6F-1 designation. However, the U.S. Navy refused to sign a contract with them. So, the first true production variant was the F6F-3. The Navy started receiving these fighters in January 1943. Navy pilots welcomed the arrival of this massive new warbird with plenty of enthusiasm. When it came to combat and flight performance, it was head and shoulders above its predecessor, the F4F Wildcat. The only thing the Navy was not happy about was the lack of hardpoints for external ordnance. Out of the box, the fighter only had a single centerline hardpoint for a drop tank. But Navy ground crews quickly figured out a workaround. They took it upon themselves to rig up underbelly shackles for 2 bombs. These weighed up to 1,000 pounds each. Under the wings, they mounted rails for launching 6 to 8 HVAR unguided rockets. Now the Hellcat could deliver devastating strikes against ground and naval targets. In mid-1943, a small batch of specialized F6F-3E and F6F-3N night fighters rolled off the assembly line. Their defining feature was the ANAPS-6 radar. This was housed inside a radome on the leading edge of the starboard wing. This radar was developed with heavy technical assistance from British engineers. The whole setup weighed around 250 pounds. However, it allowed pilots to reliably paint enemy bombers from 4.5 to 5 miles out, even in pitch blackness. Later in 1944, the F6F-3 received an upgraded engine, the Pratt Whitney R-2800-10W. It featured an anti-detonant water injection system. When war emergency power was activated, engine output spiked to 2,200 horsepower. This gave the pilot a vital edge in a dogfight. Production of the Dash 3 officially wrapped up in late April 1944. By that time, Grumman had built over 4,400 of these airframes. This included 167 dedicated night fighters. One of the F6F-3's biggest advantages was its incredible survivability. The fighter could make it back to the carrier even after soaking up a massive amount of enemy fire. The secret was its rugged, all-metal airframe and heavy armor. The cockpit and oil system were shielded by steel armor plating. This armor weighed a total of around 200 pounds. Throughout 1943 and 1944, the Hellcat became the U.S. Navy's premier carrier-based fighter. You could safely say it carried the lion's share of the air war across the Pacific. Naturally, the design continuously evolved during mass production. Over the course of the run, Grumman continually refined the aircraft. They gradually ironed out its teething problems. For example, a landing light under the port wing eventually became standard on all-day fighters. The antenna mast placement shifted as well. Early on, it was canted forward, but later it was straightened and offset slightly to the side for better aerodynamics. Engineers systematically stripped away excess drag. They removed certain machine gun fairings, deleted the lower engine cowl flaps, and smoothed out the exhaust blisters. One of the most significant upgrades was the integration of that more powerful R2800-10W engine with its water methanol injection system. And toward the end of the Dash 3's production run, the fighter was finally factory-equipped with underwing zero-length launchers for unguided rockets. Eventually, the base F6F-3 was replaced by a new, vastly improved variant, the F6F-5. This model boasted better armor protection and a redesigned windshield. It featured 3 pieces of armored glass instead of just one. Designers ditched the rear vision windows behind the canopy. They streamlined the engine cowling and added spring-loaded trim tabs to the ailerons. They also significantly beefed up the tail section. They added reliable bomb racks and zero-length rocket launchers. Even though the power plant remained the same, the fighter's total payload jumped to 3,400 pounds. Some F6F-5s received a heavier punch. Their 2 inboard 50 caliber machine guns were swapped out for 20mm Hispano cannons. Each cannon was provided with 200 rounds of ammunition. Every single F6F-5 rolled off the line wired for radar. There was space right on the instrument panel for a scope. Thanks to this, any standard Hellcat could be converted into a fully capable night fighter in just a few hours. Grumman rolled out a total of 7,870 of these fighters. This included the purpose-built F6F-5N night fighter variant. On top of that, over 1,300 Hellcats were supplied to Great Britain under Lend-Lease. There, they successfully took the fight to the Axis. In December 1944, the U.S. Navy set up a real showdown. They flew comparative mock dogfights, pitching their F6F-5 against a captured Imperial Japanese Navy prize, the A6M Zero. The results were telling. The Hellcat was noticeably faster in level flight across all altitudes. Right down on the deck, it outpaced the Japanese fighter by 41 miles per hour. Climbing up to 15,000 feet, the American aircraft pulled ahead by 62 miles per hour, and at 30,000 feet, its speed advantage stretched to 66 miles per hour. However, the Zero still had its strengths. At altitudes up to 9,000 feet, it outclimbed the American fighter by about 590 feet per minute. In the mid-altitudes, right up to 14,000 feet, the climb rates of the 2 airplanes were dead even, but as they pushed higher, the heavier American fighter surged ahead again. It outclimbed the Zero by 490 feet per minute. The Imperial Japanese aircraft was much more maneuverable. It boasted a superior roll rate at speeds under 230 miles per hour. But the second the airspeed indicator crossed that mark, the F6F completely took the initiative. In sustained level turns, especially at low speeds right above the water, the lightweight A6M absolutely dominated. In just 3.5 turns, it could complete a full 360-degree circle inside its opponent. But when it came to boom and zoom tactics or high-speed dives, the heavy, rugged Hellcat was the undisputed king. In the second half of 1944, the landscape on American carrier decks began to shift. Chance Vought had finally ironed out the kinks in their F4U Corsair. This made it safe for shipboard operations. With objectively superior performance specs, the Corsair quickly began pushing the Hellcat aside. It became the premier fighter of the U.S. Navy. Despite this, the F6F remained a formidable weapon that easily outclassed most Imperial Japanese aircraft. Thanks to its hefty payload of rockets and bombs, it found a new calling. It excelled as a fighter bomber and flew close air support for ground troops. And as a radar-equipped night fighter, it remained unmatched for a long time. Still, time was catching up. Navy brass decided the airframe had reached the end of its development potential. Because of this, any further attempts to modernize the Hellcat were scrapped. Besides, a new, even more ambitious project was already on the horizon. Grumman's engineers were hard at work on the successor to the legendary Wildcat and Hellcat, the F8F Bearcat. Looking back at how it all started, the first Hellcats reached combat squadrons in January 1943. They first saw action on August 31st, escorting bombers during a major strike on Marcus Island. The very next day, Hellcat squadrons flying off 3 fleet carriers and 3 light carriers established absolute air superiority during the amphibious landings on Baker Island. That is also when they scored their first official kills, splashing 4 massive Imperial Japanese Navy Kawanishi Emily flying boats. From then on, the Hellcat became a true workhorse of the Pacific War, flying combat air patrol over the fleet and escorting strike packages during key campaigns, especially the major offensive against Rabaul. In early December 1943, Hellcat pilots got their first real chance to flex their combat muscles in a large-scale dogfight. This happened while flying cover for the invasion of Kwajalein Atoll, a massive formation of 91 Hellcats tangled with 50 legendary Imperial Japanese Navy Zeros. The results were staggering. The Americans shot down 28 enemy planes while losing only 3 of their own. This kind of lopsided victory made perfect sense. For one thing, the American pilots were incredibly well trained, with plenty of flight hours and real combat experience from flying the Hellcat's predecessor, the F4F Wildcat. On the flip side, the quality of Imperial Japanese aviator training had already taken a noticeable nosedive. But the biggest factor was the aircraft itself. You just cannot overstate the Hellcat's incredible ruggedness, high top speed, and acceleration. And the devastating firepower of a burst from 650 caliber machine guns simply left enemy pilots with no chance. Thanks to its generous wing area and excellent aerodynamics, the Hellcat could, if pressed, hold its own in a turning fight against capable Imperial Japanese fighters like the Ki-61 Hien or the Mitsubishi Raiden. However, in a flat turn, the light and nimble Zero was still the undisputed king. So against it, Hellcat pilots stuck to classic, highly effective boom and zoom tactics. Plus, if things got too hot, the American pilots could safely break off at any time. They would just execute a split S, rolling the aircraft hard on its back and pulling through a steep half-loop dive. A Zero pilot simply could not follow them down because at those extreme dive speeds, his fragile airframe could literally break apart in midair. It is worth noting that even for a carrier-based fighter, the structural strength of the Hellcat was legendary. All the fuel tanks were self-sealing to close up bullet holes and were additionally backed by steel armor. The pilot essentially sat in an armored box. Heavy armor plates protected him from the front and rear, while a solid armored floor plate guarded him from below. The armored glass of the windscreen could easily shrug off direct hits from rifle-caliber machine guns. This incredible level of protection and survivability turned the Hellcat, especially its most famous variant, the F6F-5, into a highly effective ground attack aircraft. It did a brilliant job providing close air support for ground troops during major amphibious landings. The upgraded F6F-5s started packing the decks of American carriers in August 1944. Production ramped up so fast that the Navy was quickly able to replace not just the aging Wildcats, but even the early model Hellcats. A defining moment for these warbirds came on October 10, 1944. It happened during the massive air operations around the Battle of Leyte Gulf. American air power decimated over 100 Imperial Japanese aircraft. Exactly 25 of those were credited specifically to Hellcat pilots. On that single day alone, Commander David McCampbell shot down 6 enemy airplanes. He was the top-scoring ace in U.S. Navy history. He racked up 34 aerial victories during the war. Other legendary aviators forged their legacies at the controls of the mighty F6F. Cecil Harris achieved 24 kills. Eugene Valencia reached 23, and Alexander Vrasiu secured 17. So it is no surprise that the Navy gave this fighter a highly fitting nickname. They called it the Ace Maker. Right up to the end of the war, these aircraft operated at full throttle. They launched from the decks of fleet carriers as well as land-based airstrips. However, when the fighting shifted directly to the skies over the Japanese home islands, the Americans faced much deadlier opponents. These included the latest Imperial Japanese Army fighters like the Ki-84 Hayate and the Ki-100. On paper, these fighters outclassed the Hellcat in almost every metric. They were faster and had a superior climb rate. They also boasted better maneuverability and packed significantly heavier firepower. As a result, American aviation losses started to mount. A highly telling encounter took place in early August 1945. The famous Imperial Japanese Navy ace, Lieutenant Tetsutsu Iwamoto, was flying his Kawanishi Shidenkai fighter. This plane was known to the Allies as the George. He engaged in a fierce dogfight with a flight of 6 Hellcats entirely on his own. Despite the overwhelming odds, he masterfully shot down 4 American aircraft. The 2 surviving F6Fs emptied their guns in a desperate attempt to nail the Imperial Japanese pilot. When the stunned Americans finally made it back to their carrier, they filed an after-action report. It stated that the enemy pilot boldly forced the engagement. It tore their formation apart and broke away into the sky with absolute impunity. During the war, radar-equipped night fighter variants of the Hellcat also saw heavy use. However, their success was a bit more modest compared to daytime operations. In the latter half of the war, their primary targets were Imperial Japanese bombers. These bombers operated mostly under the cover of darkness. However, the success rate for these night intercepts remained notoriously low. This came down to both the primitive performance of early airborne radar and clever Imperial Japanese tactics. On the ingress to the target, enemy bombers flew in widely scattered groups. They only tightened up their formation right before the bomb release. On top of that, Imperial Japanese bombers were often escorted by the legendary Zero. This aircraft boasted an incredible combat radius. The American Hellcat, on the other hand, knocked about 20 knots off its top speed. This was due to the bulky radar pod mounted on the wing. Its maneuverability also took a serious hit from the extra weight and drag. Despite these hurdles, a major change was made in 1944. The light aircraft carrier USS Independence was specially reconfigured. It was set up exclusively to serve as a night fighter carrier. Generally, these night fighters flew off escort carriers. They operated across the Pacific, Indian, and Atlantic Oceans, and even up in the Arctic. Hellcats supplied to the Royal Navy Fleet Air Arm saw combat in both the Atlantic and Pacific theaters. A few British Hellcats even took part in a daring strike against the German battleship Tirpitz. The ship was hiding out in a fjord in northern Norway. The contribution of the Hellcat to the victory in the Pacific was absolutely colossal. In just 2 years of heavy combat, American pilots flying the F6F destroyed 5,156 enemy aircraft. To put that in perspective, that accounts for a whopping 75% of all aerial victories. These were scored by U.S. Navy aviators during the war. Meanwhile, combat losses amounted to just 270 F6Fs. That leaves the Hellcat with a genuinely staggering kill-to-loss ratio of 19-1. When the war ended, all the remaining F6F fighters were transferred to the Navy Reserve at shore bases. But they did not just sit idle, they kept flying. The thing is, these were some of the most forgiving and easiest to fly aircraft in the U.S. Navy. That made them perfect for training new pilots. And when the Korean War broke out, these veterans ended up spending about another year in the combat zone. They were mostly flying secondary missions by then. What is really fascinating is that some of these aircraft were converted into unmanned flying bombs. The Navy used them to strike dams, heavily fortified bunkers, and other critical point targets. To pull this off, ground crews packed the fuselage with around 3,300 pounds of explosives. They also rigged them with a radio control system. These Hellcat drones would head straight for the target on their own. They were guided by an operator sitting safely aboard a controlling aircraft. The Hellcat was finally retired from U.S. service in 1951. Most of them were either scrapped or sold off to the civilian market. Today, only about 20 of these aircraft survive worldwide. They are scattered across private collections and aviation museums. And what is most impressive is that the majority of them are still airworthy and actively flying. The overall production numbers for the Hellcat were seriously staggering. By April 1944, the Grumman plant had cranked out 4,401 units of the F6F-3 variant. By November 1945, another 7,870 of the updated F6F-5 had rolled off the assembly lines. It is also worth mentioning that Hellcats were heavily supplied to Great Britain under the Lend-Lease program. The Royal Navy received a massive fleet. This included 252 F6F-3s, 849 F6F-5s, and 76 specialized night fighters. All of these aircraft went through additional modifications at Blackburn aircraft plants. For example, the base F6F-3s were outfitted with launch rails for British rockets. Meanwhile, some F6F-5 models were completely converted into high-speed photo reconnaissance aircraft. Crews stripped out the machine guns to save weight and boost top speed. During the course of the war, British Hellcat pilots officially claimed 60 enemy aircraft shot down. 47 of those victories happened in the Pacific Theater, and another 13 were scored in the skies over Europe. Shortly after World War II ended, the surviving Hellcats were returned to the United States. But the combat record for the Hellcat did not stop there. When the First Indochina War kicked off in 1945, France was still reeling from the German occupation. The country found itself with practically no combat aviation of its own. To back up their ally, the U.S. government handed over a batch of Hellcats to the French in the early 1950s. This included both standard F6F-5s and night fighter variants. Flying over Vietnam, French forces primarily used these heavy-hitting fighters as attack aircraft to provide close air support for ground troops. On top of that, a small batch of Hellcats was transferred to the militaries of Argentina and Uruguay as part of foreign military aid programs. Here's a fun fact. The final group of 12 fighters was not retired from the Uruguayan Navy until 1961. This just goes to show how incredibly reliable and durable the airframe really was. Looking at the technical specs, the Grumman F6F-5 Hellcat was a rugged, all-metal, low-wing monoplane. Flown by a single pilot, the fighter was powered by a massive twin-row radial engine. Even though the overall airframe was quite heavy, it more than made up for it with incredible structural strength. It offered absolute reliability in combat, and overall ease of maintenance and manufacturing. All of this made the Hellcat absolutely ideal for mass production. The aircraft's fuselage featured a classic semi-monocoque design. It was skinned with tough aluminum alloy. Structurally, the fuselage was broken down into three main sections. Up front sat the heart of the fighter, the engine. Also located here were the water injection system, fire extinguishers, and the oil tank and cooler. This section ended at a heavy firewall, which served as the mounting point for the wing spars. The center section housed the main fuel tank and the cockpit. The pilot was protected by heavy armor plating. This included a solid forward plate, an armored seat back, and a half-inch thick floor plate. The aft fuselage housed the radio gear, direction finder, retractable tailwheel, and the arresting hook. The empennage was solidly bolted to this aft section. This tied it all together into a single, rigid structure. The cockpit was fully equipped with all necessary flight and navigation instruments, an autopilot, and engine gauges. The plexiglass canopy was a two-piece unit. The sliding section rolled smoothly backward. In an emergency, it could be jettisoned by the pilot or externally released by the ground crew. The windshield was a tough, 1.5-inch thick armored glass block. It was designed to withstand direct enemy hits. On top of that, it featured an alcohol de-icing system. This kept the glass from frosting over at high altitudes. The aircraft's wing was built around three structural spars. It featured folding outer panels. This was an absolute necessity for spotting on cramped carrier hangar decks. A dedicated hydraulic system powered the wing fold. The fixed center section of the wing housed two more fuel tanks and the main landing gear wheel wells. The folding outer panels housed the aircraft's armament. This included the heavy machine guns, ammunition boxes, landing lights, and the hinge points for the ailerons and flaps. The flaps could be lowered to 27 degrees for takeoff and 55 degrees for landing. This provided excellent low-speed handling. Both the ailerons and flaps were skinned with light aluminum. This skin was roughly 60 thousandths of an inch thick. The heart of this fighter was a massive power plant, the Pratt Whitney R-2800-10W Double Wasp. This air-cooled, 18-cylinder radial engine had a displacement of 2,800 cubic inches. The engine was backed by a two-stage supercharger. It also featured an innovative water alcohol anti-detonant injection system. At takeoff power, this power plant cranked out an impressive 2,028 horsepower. Thrust was provided by a three-blade metal Hamilton Standard hydromatic constant-speed propeller. It measured 13 feet and 1 inch in diameter. If the pilot needed a sudden burst of speed in combat, the water alcohol injection system provided war emergency power. This allowed them to briefly push the engine's output to 2,231 horsepower. However, WEP could only be engaged for a maximum of 5 continuous minutes. The fighter's fuel system included 3 internal tanks. 2 87-gallon main tanks were located in the wing center section. A 75-gallon reserve tank sat tucked right under the cockpit floor. For long-range missions, the aircraft could carry additional drop tanks. These included a large 150-gallon centerline tank under the fuselage and 2 smaller 100-gallon tanks under the wings. A 19-gallon oil tank was mounted just behind the engine. A dedicated oil cooler in the lower fuselage automatically maintained optimal oil temperatures during flight. An engine-driven hydraulic system actuated the aircraft's primary mechanical components. It operated the flaps and adjusted the cowl flaps for engine cooling. It cycled the landing gear and folded the wings. It also operated the wheel brakes and the remote charging mechanisms for the wing guns. The fighter's landing gear featured a classic conventional tailwheel setup for its time. In flight, the main struts didn't just fold up into the wings. They rotated 90 degrees to lie flat inside the wheel wells, tucking in flush with the wing. This elegant engineering solution saved a ton of space inside the airframe. The tailwheel was quite small. Instead of a standard pneumatic tire, it used a solid rubber tire that retracted up into the tail section. Normally, the landing gear was lowered using hydraulics. If that system took battle damage, the pilot could always drop the gear manually using an emergency backup system. The radio setup on board this aircraft consisted of a few key components that ensured reliable operation in flight. Pilots had a radio suite with shortwave and medium-wave transmitters providing stable two-way communication. On top of that, a dedicated long-wave navigation receiver was used for precise aerial navigation. The avionics suite also included an IFF system. It featured a dedicated self-destruct mechanism to guarantee this classified tech wouldn't fall into enemy hands under any circumstances. All this complex radio gear was securely tucked away inside the fuselage, in a roomy equipment bay between the cockpit and the empennage. To keep the communication systems running flawlessly, the aircraft was fitted with 3 antennas. These included 2 whip antennas and 1 wire antenna. The latter was a tensioned metal cable pulled taut between 2 masts. One of these masts was mounted right behind the cockpit. The other sat all the way back on the vertical stabilizer. Now for the best part, the armament. This bird packed a truly devastating arsenal. It carried 6 heavy 50 caliber Browning M2 machine guns. Each gun was fed by a 400-round ammunition belt. On some later versions of the fighter, specifically the F6F-5 model, the firepower was bumped up even more. Instead of a full 6-gun battery, engineers swapped out the 2 innermost machine guns for heavy-hitting 20mm Hispano Mark II cannons. Each cannon carried 200 rounds. But that's not all. Underneath the wings and fuselage, you could mount up to 3 heavy bombs weighing 1,000 pounds each. On top of that, the fighter could haul 6 5-inch HVAR rockets. It could also carry 2 massive 11.75-inch Tiny Tim unguided rockets mounted on special reinforced racks. To seriously stretch its range, external drop tanks could be attached under the center fuselage. The pilot could easily jettison them mid-air once they ran dry, shedding that dead weight before engaging in a dogfight. And on the F6F-5 variant, those exact same drop tanks could also be mounted right under the center wing section.